So to recap, there are two theories of intelligence: knowledge and learning. And those each spawned their own branches of artificial intelligence, symbolic AI and machine learning. And the learning sub-theory also spawned another theory that the brain structure is the reason why we as humans are smart, so we should replicate it by creating neural networks, and that is what gave us deep learning. Great. So now, everything, almost everything that you hear is machine learning or deep learning. And symbolic systems are still around, but they're far less common. So what is machine learning? The cut and dry of this is that machine learning is the process of using statistics to find patterns in data. And then the second part is it uses those patterns to then make decisions. So you can kind of think about it like humans. We live our experience, we learn lessons from those experiences, we then apply those lessons to our actions and decisions. Machines, the data is the experience for them, so they learn the lessons from the data and then apply those lessons to their actions and decisions. So machine learning can be applied to image data, and it's extracting pixel patterns. You can feed it text data, and it'll extract word patterns. You can feed it audio data, it'll extract sound patterns. Essentially, any kind of data that you can put into digital form, you can feed into a machine learning algorithm, and it will find a pattern for you and then apply it as you wish. So there are two stages to machine learning. There's the training stage and the deployment stage. In the training stage, you take your data, you feed it into the algorithm, and it develops what we call a machine learning model. And that model is essentially the codified version of the patterns or the set of rules that the machine helped you write. And then you can take new data, put it into that model, and the model will compute what your desired output is. So here's a very simple example. Let's say you have data that is cat images. You feed it into a neural network, your algorithm, and the model is essentially the pixel patterns that make a cat a cat. So then you can go and feed it new data. Maybe you have an image of a muffin. You feed it into your model, and hopefully, with some success, it will tell you that this is not a cat. So here's a pretty nice animation of this process happening. Here we have the neural network. That's the algorithm, and then we have both cat and dog photos that we're feeding in that are labeled. So we're telling it, these are the cat photos, these are the dog photos. And it creates the model known as a trained neural network. And then that trained neural network can now tell you that this image is of a dog. So this process is actually really simple, but it's really powerful for a whole host of applications. So you can see that for image recognition, that's what drives face recognition. It's also what drives medical diagnosis, which is a really big budding field in artificial intelligence because a lot of medicine is based off of understanding and interpreting images like MRI scans or CT scans. It drives speech recognition, so you can transcribe your voice. That's how, in part, you can communicate to Siri and Alexa. And if you recently had your bank turn on voice identification, where it essentially adds a security layer to recognize your voice, that is also basically a form of speech recognition. Text prediction is like autocomplete or autocorrect on your phone. Ranking systems are the less obvious one. They are essentially the systems that Google uses to organize the search results in your search feed and what Facebook uses to organize the posts in your news feed. So it's essentially taking data, which is your engagement and clicks from before, and finding the patterns that help it predict what you might like to see first versus last. And then recommender systems is particularly important in marketing. It's the reason why you get very good product recommendations on Amazon, and it's also what's behind all of the targeted ads that follow you on the internet. So you might have noticed that each of these groups essentially try to mimic a human skill. As Paul mentioned before, these are all in quotes because they don't actually mimic it, or they don't actually get to what it is, but they do loosely mimic it. So image recognition is like sight, text prediction is like writing, so on and so forth.